Hello everyone and welcome back to the course. In this lesson, we will learn about collision in Unreal Engine. We'll understand how it works, how we can set it up correctly, and finally, how we can detect overlap between blueprints. Let's get started. Before we jump into Unreal, let's take a moment to learn about collision in the engine. Collisions are part of the chaos physics system in Unreal Engine. Every blueprint actor is assigned an object type. So for example, we could have a bench as a static object, an elevator as a dynamic object, a car as a vehicle object, and the player as a pawn object. Each object also has a set of responses for all available object types in the engine. The possible responses are ignore, overlap, or block. So for every object type, each blueprint actor can decide whether to ignore, overlap, or block each of the object types. You can also add your own custom object types to your project, which gives you a lot of flexibility in how you handle collisions. And finally, you can use special events to get notified when collision events occur and use that in your code. For example, hit events notify you when a block or collision has occurred, and overlap events notify you when an overlap has occurred. Now let's jump into Unreal and see how it's done. And now that we're back in Unreal, let's go ahead and take a look at those collision settings we just learned about. Let's go ahead and right-click in our content browser, click on Blueprint Class, click on Actor Class, and let's name our new blueprint BP_floor. Double-click to open it. Let's add a cube component as we've done before. Let's scale it to 5, 5, and 0.2. Let's go ahead and compile. And we have a small floor or platform that we're going to use to learn about collisions. If we select our cube component here, we can go to the details panel and scroll down. There will be a collision section. You will see that we have some collision presets available. And if you click the drop down, you'll see that we have quite a few. Default, custom, no collision, block all, overall, etc. If we click on custom, you'll see that automatically we have all of our options down here become available. The first thing and most important thing you should notice is this object type. As we talked about it before, every single actor blueprint in the engine is assigned an object type. So let's click on the drop down, and you can see that by default, Unreal comes with these object types: world static, world dynamic, pawn, physics body, vehicle, and destructible. And as we saw before, we have a table where we can define the actual response, whether it's ignore, overlap, and block, for all of the different objects. You'll also notice that we have trace responses, visibility, and camera, and we will talk about this in a future lesson. But for now, you can see that our floor is going to block all of the different object types that we have available in the engine. So if we go ahead and compile, go back to our level, we can actually test this out. So go ahead and click and drag your floor to your level. We're going to make it a little taller here, and let's add a sphere. So click on the add menu here, go to shapes, and click on sphere. And let's go ahead and make sure that we are aligning our sphere so it falls on our floor. There you go. And let's give our sphere a different material to make it a little bit more visible. You can go to the details panel here, scroll to the materials section, click on the drop down and select any material from the list. There we go. And finally, if I scroll down to the physics section, we are going to click on Simulate Physics. So go ahead and enable that checkbox. And now if we click Simulate, let's see what happens. Our sphere falls and hits our floor and stops there. Go ahead and stop the simulation. And that is because, again, if we go down to the collision settings here, we see that our sphere by default has a preset of physics actor, which you can see here, even though is a little bit dark, you can see that physics actor basically has a collision response of block for all other object types. And because our floor, let's go ahead and go back, has an object type of world dynamic, the sphere will block all of the world dynamic objects, as you can see here. If we were to change our settings on our BP floor, so let's go back, and here on the object responses, instead of blocking, we would simply change this to overlap to physics body, which is what the sphere is. If we compile and go back to our map, let's see what happens when we click Simulate. Our sphere falls through our floor and under the actual big floor on the level. It has overlapped our floor. Let's go ahead and stop. Go back to our blueprint. As you can see, you have a lot of control on how your blueprints respond to every single other object type. But we can do more than that. Go ahead and compile and go back to our level. As I mentioned before, we can actually create custom object types for our game. Let's go ahead and do that now. Click on Settings, Project Settings. Let's go to the collision section right here. And you'll see that we have an object channels section here. And you can see that we have the ability to add up to 18 custom additional channels for objects and traces. So let's go ahead and click on New Object Channel. And let's name this Boulder. And you have the ability to set the default response that every other blueprint in your game will have. So our boulder will be applied to our sphere, kind of like a boulder falling. And I want the default response for every blueprint in our level to block our boulder. So let's go ahead and accept. And now if we go back to our floor, nothing has happened. And that is because we need to close and open the blueprint to refresh the list here. So let's go ahead and save it. I'm going to close it. And if we double click to open it again, click on our cube, go down to collision. Now you see that we have a new category here called boulder. And as expected by default, it is blocking the boulder here. So if we go back to our map, we can select our sphere, and under collision, let's click on a custom preset. So we can change our object type from physics body. Whoops, we need to deselect and select the blueprint again to refresh it. Now we have the boulder option here, and if we click on the object type, we can now select boulder. Let's go ahead and simulate and see what happens. As expected, our floor is blocking our boulder. The last thing we want to show is how to use our custom events to detect whether we are blocking or overlapping an object. And we have custom events that tell us just that. So let's go back to our BP floor blueprint. And here you'll see that on the event graph, by default, we have event begin play, on actor begin overlap, and event tick. But if we click on our component here and right click, you see that we have a menu that says add event. And if we select it, you see that we have a lot of different events that we can attach to our cube. Let's go ahead and select add on component hit. Let's right click again. And this time let's select on component begin overlap. And one more time, let's select on-component end overlap. On-component hit will be triggered when there's a block detected, and overlaps, begin and end overlaps, will be triggered when an overlap is detected. However, we need to be explicit and tell Unreal Engine that we actually want to fire these events. So let's go ahead and click on our cube. And right here, you'll see under collision, if we collapse this list, we already by default have generate overlap events enabled. That means that by default, if there is an overlap, these two events will be triggered with an overlap. However, if we want to detect a hit, we need to explicitly enable simulation generates hit events. Let's go ahead and click here. And now if we compile, now we know that when there is a hit or a block, this will fire, and when there's an overlap, this will fire. And an easy way to test this is to simply add a print string here to make sure that this event is actually firing. So you'll notice that on this event, we have a lot of really good information. We have the hit component, the other actor or the actor that actually hit our component, the other component, we have an impulse normal, and we have a hit. And this is a struct or a structure. And if you recall from a previous lesson, a structure is a collection of variables of different types that are grouped together. So really quickly, if you click and drag and let go, you'll see that we have an option to break the hit result. Go ahead and click there. And you'll see that if I expand this, we have a lot of information that we can derive from our hit. We're not going to use this information in this lesson, but I wanted to showcase it now because you'll find out that this information is extremely useful when we're creating functionality. When an object hits our blueprint, we can clearly see where it hit, location, the normal, if it has a physical material, the name of the actual actor, if there's a bone, what's the bone name, etc. So let's go ahead and delete this. And for now, we're simply going to add a print string. And if you recall, I mentioned that strings have a string library and can be manipulated. There are a lot of different functions that you can use to manipulate your strings. One of the most useful things you can do is append or combine strings together. So let's go ahead and click and drag, and let's search for append. Select it, and you'll see that this node basically takes two strings and puts them back together and returns one string. So for this example, we'll simply drag from other actor into the first pin here, A, and Unreal Engine will automatically create a node called getDisplayName. Very convenient. So when our cube is hit, we're going to grab the name of the hit actor and we're going to display it. So for the second entry here, we'll simply add space hit us. And now if we compile and go back to our map, let's see what happens. Let's click on simulate. As you can see, sphere hit us is triggered several times as the ball bounces and hits our floor. Let's go ahead and stop. Go back to our blueprint, and let's do the same thing here for begin overlap and end overlap. But instead of hit us, we'll simply say overlapped us. And for this example, we won't add anything to the end overlap. Let's go ahead and compile. And now to test the overlap, let's click on our cube component here and go down to our collision, expand our collision presets, and let's change our response to boulder from block to overlap. Let's go ahead and compile. Let's go back to our map and let's click on simulate. And something strange is happening. Our boulder clearly went through our floor and overlapped, but for some reason the overlap event wasn't triggered. So let's go ahead and stop. And with our sphere selected, let's go down to the collision settings here. Let's collapse collision presets. And we'll notice that generate overlap events is not selected. So specifically for overlap events, both objects the object that is colliding and the object that is receiving the collision both need to have generate overlap events enabled. And that is by design and for performance reasons. Notice that that is not the case for hit. In this case, our blueprint here does not have generate hit events, our boulder rather, yet it still generated a hit. But for overlaps, because they're more costly, you have to explicitly tell Unreal Engine that yes, both objects want to generate overlap. So now if we click on Simulate, you see that we have sphere overlapped us here. Let's go ahead and stop. As you can see, the collision system in Unreal Engine is rather simple to understand, but very, very powerful. You can add up to 18 custom object types to your game and change the collision response per object type for any blueprint class in your game. Alright, let's go ahead and do a more practical example. So let's click on our sphere and our platform. We can go ahead and remove them from our level. And for this next example, I like to use the platform we've been working on. So let's grab and open our BP platform here. And how about instead of having the platform automatically start moving on begin play, we create a trigger that the player can step on to activate and deactivate the platform. So the first thing we'll do is, if you see here on begin play, we are setting our starting location and our play rate. We actually don't need to call go forward here on begin play, so we can go ahead and disconnect it here. So alt click, and now the platform won't start automatically. The second thing we want to do is we want to add a volume that will act as a trigger. So if we go to our viewport and right here click on the add components, let's scroll down and see what we have available. And you'll notice that we have a collision section that has box collision, capsule collision, and sphere collision. Perfect. Let's go ahead and select the box collision. And let's resize it so it's the same size as our platform. Alright, there we go. So we have a box collision that is roughly the same size as our platform. And we want to make it a little bit higher, so even if the player jumps, as soon as it overlaps, it'll activate our platform. So let's go ahead and compile. And just like before, we want to add the begin and end overlap events to our box trigger. So right click and let's add begin overlap and end overlap. Okay. And all we need to do now is when we begin overlap, we just call the event go forward. So click and drag and let's search for go forward. Let's go ahead and compile and let's see what happens now. Let's drag our platform to the world and you can see that now we have our trigger visible. And let's move our end location to a new place. Alright, and now instead of clicking simulate, we want to actually click on the menu and click on selected viewport. That way, as you can see, our player spawns and now we can walk towards the platform and see what happens. Perfect. We have a bit of clipping, so we need to move the platform, but you can see that the platform activated as soon as I stepped in. However, the platform is not stopping, and that is going to be the next thing we work on. Let's go ahead and click escape to stop. And let's move the platform a little bit so there's no clipping. We can raise it a little bit here. There you go. And now if we go back to our platform, we have an event that starts the whole process, as you can see here, and it'll go back and forth indefinitely. But notice that we have another pin called stop. So very easily we could create a new custom event that simply stops the timeline, effectively stopping our platform wherever it is. So let's go ahead and do just that. Let's add a custom event. Let's name it stop. And now all we need to do is connect it to our pin. Alright, and now let's go back down and add our event stop to the end overlap. There's one more thing we can do. As soon as we step in, the platform immediately starts moving. So it would be nice if we could have a small delay to allow the player to step in and position itself in the middle of the platform. So let's go ahead and add a small delay before the go forward here. And in this case, let's just make it 1 second. Perfect. Now let's compile and go back and test. And if we click on play, okay, let's see what happens now when we step over. We start moving, but somehow we stop moving. And we can see that something is clearly going on with our blueprint here, as it seems to have some erratic behavior. So let's go ahead and stop and think about what's going on here. If we go back to our blueprint, and we go back to our viewport, we'll notice that we do have our trigger here that is sized correctly to the platform. However, notice what is happening on our movement code here. If we go back to our event graph, our code is moving the relative location of our cube, which is our platform, but the box itself is not moving. So we have our starting position here and the player hops on, it triggers the begin overlap, but as the platform moves out and the trigger stays in the same place, we are unfortunately triggering the end overlap as the player moves out of range. So what needs to happen is that we want our trigger to move with our platform. Otherwise, it won't work as intended. And the easiest way to do that is to simply parent our box component to our cube. So all you need to do is click and drag. And you can see here you have the little check here. And when you let it go, you'll see that now our box is a child of cube. So cube is now the parent of box, and now as we move our cube, our box collision will move with it. So let's make sure that we compile again, and let's go back and test one more time and see if that fixes the issue. Click on play, and let's go back and step on the platform. And as you can see, everything is now working as intended. And if we step off, we are stopping our platform from moving. And if we jump back on, the platform begins to move. However, there's still one more thing that we should probably address. If we wanted to have our stop when the platform reaches its destination to be more than 0.2 seconds, let's see what happens here. Go ahead and stop, and let's select our blueprint here, and for our stop duration, let's make this 1 second and test one more time. Click play. Now step on the platform, and you step off as soon as it reaches its destination, and look what happens. Somehow we broke our functionality. Why would the platform continue to work even though we actually triggered the stop event? Let's go back to our blueprint and see what's going on here. So go to the event graph, and you can see that clearly we are triggering the event end overlap and hitting stop. So that should obviously stop our platform. Remember what I mentioned about delays. Once a delay is triggered, that code will execute when the delay is finished. So what is clearly happening is we are reaching our end destination, we are triggering our delay, we are stepping off of the platform, which then triggers the stop custom event, we are stopping the timeline, but then the delay finishes and immediately goes and calls either go back or go forward. That is the reason why when you're stopping at the end or beginning of the platform trajectory, the platform seems to continue working, and that is because we have delays here. So an easy way to do that is to put a check right here when we're calling these events to make sure that the player is still on or off. And we can do that very easily with a Boolean. So what if we created a Boolean and called it player on? And that Boolean will represent whether our player is on or off our platform. And all we will need to do now is add a branch between go forward and go back to check that the player is still on the platform before calling those pins. So let's go ahead and do that now. And now we see that it doesn't matter when we call our go forward and go back, we will always check whether the player is on or off. So all we need to do now is set the variable to true or false whether the player is overlapping our platform or not. So let's go down. And now all we can do here is simply set our variable before we call these events. Let's make some space here and simply drag player on and click set player on. And in this example, when we overlap our trigger, we want player on to be true. And we'll do the same for end overlap here. But in this case, we want player on to be false. Let's go ahead and compile. And let's think about our logic one last time. When we overlap our trigger, we set our boolean player on to true, we wait a second and we call go forward. When we end the overlap, the player steps off the platform, the variable player on is set to false, and then we hit stop. So what happens is, even if the player steps off while we're still doing a delay, once the delay finishes and it calls either go back or go forward, those custom events will yet again one more time check whether the player is still on or off. If the player is on, only then will you then actually call the timeline and execute the movement. Otherwise, nothing will happen. So one last time, let's do one final check. Click on play. Step on the platform. And now everything seems to be working as intended. The platform is not moving even after we exit the platform during that delay. And there you go. Now let's do a quick recap. Collisions are part of the chaos physics system in Unreal Engine 5. Each blueprint actor is assigned an object type, and each object type can ignore, overlap, or block other object types. You can create custom object types for your game. You can use the onHit event to detect blocks. And you can use the event begin overlap and event end overlap to detect overlaps. If you want to practice what we learned, think of 3 examples where you would want to detect overlaps in your code. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.